Okay, welcome to this lecture. This is going to be a lecture about chops, channel operators, and also about mixing paradigms, meaning that how we're going to use chop networks to control, for example, parts of our geometry. Because the most obvious thing to use chop networks, since they're mostly time related, would be animation. But I'm going to show you how exactly you can combine things just in another way. Okay, so basically what I did was I created a simple setup in which I created a box. I made sure that the box was just resting on the ground over here. And I also created a circle with some resampling points, and also over here some orientation attributes, which you can find in the video lecture going about the copy swap number 4, aligning objects in a copy swap. Right, so this is basically it. So the idea what we're going to do right now is, first of all, we're going to create a chop network right inside this existing network. So where you used to know where it was is over here. So these are channel networks, but what we're going to do is to add them right in here. And that's very useful because imagine if you want to create like a very complex digital asset. You can embed like all those channels, all those controls right inside the same graph, the same digital asset, without having to refer to all kinds of other parts, making it horrendously complex. Okay, so where can we find it? That's something you find right here. So in underneath managers, you find all kinds of different paradigms that you can embed in the modeling SOPs. So this is going to be the chop network that we're going to use, chopnet. And what you can see over here, because I will go in this chopnet, is my scene view. I've added an extra pane tab over here. You can do that by pressing the plus button right here. Then you will get a new tab, and I created for this tab a context view. What this will do is whenever I change a certain context, for example going over here, you see the view is being altered, so I can go back out either by clicking over here and then just selecting the node. As you can see, the view is just jumping back and forth again. Alright, but now first things first, what I'm going to create is over here a wave node. Now this wave node, as you can see, I've shown this before. It's just a simple wave, and it's oscillating up and down every second. So it's 24 frames a second, and if you go closer, you'll see we have a repetition every other second. So starting from 1 and ending at 20 frames per second. So that's correct, and that's what you can see over here, which is the period. Now there's a lot of nice and nifty things about this. This is also important. Something that you need to check out is these are automatic constraints for the viewport, which can be sometimes annoying. So if I change over here these values, I don't see my curve changing. I see how it's being zoomed in. Now personally, I think that might be a little bit distracting, so I usually switch both of these off so that I do have like a good idea of what I'm doing. Okay, just have this simple thing with this wave output, and first thing what we're going to do is doing a little experiment over here. So we're gonna go right up, and of course with the copy node we're going to do a stamp on each of those objects. So let's just start with a stamp function. And what we're going to do is to create an expression, and you can find all those expressions for the chop editor, you can find them right over here. So if you go down, down, chops. So right here you see all the expressions that you can use to evaluate or get some information. So the one that we're going to use is over here, chop if evaluates a channel within a chop at a given frame. So what this means is that if you go right inside, is that we can read out the value of this wave at every frame. So the value over here, value over here, value over there, and so on. So just like a timeline, exactly the same principle. I'll go back up again. So over here, what I'm going to use is the chop F. I've forgotten chop F. And now you have to locate exactly what you want to have. So what does it say? It says the string of the channel, and that's very important. It's not saying that you have to go just as far as selecting the node. So let's go inside of the chopnet, and then next to that we have the wave, and then we have to select a channel. Now the pity thing is that we don't have a channel being displayed right here. That's something you can't find. These are all inputs from this node, and we can't access it directly, so you have to know what kind of name it is. So chan1 is going to be the name of it. That's the default name. And well, you see this help file, but it's just going right out of the frame. But if you have this help file, you will see first part is the string channel, and the second part is the frame. So in fact, which sample that you want to take. So the samples we're going to take from the points. So the point index of the circle, being responsible for all the copies, is going to read out the values of all those channels. So let's do it like over here. And now let's just have our typical name that we have. So yeah, again, if you want to have the channel name, that's the one you see just floating up and down here on the curve. This is the name. So if you want to know what it is or where to find it. Okay, copy. So now with a stamp, we're going to adjust the scale over here in the y-axis. So stamp, and let's do this in copy 1, and we're going to use the copy and default value of 0. So what do we get over here? As you can see, we see with nicely our wave of the node going up and down. Well, something I'm gonna change is right over here, transrotate scale. That we have our translation and then our scaling. Now, of course, let's make it a little bit more visible, times 10 or times 5. That's visible enough. As you can see now, we're just literally reading out the values. I'm going to pin down this window for now, so if I go in there, that it doesn't change. And now you will see if I just play around with the period, it is it's reading out really that wave. Well, let's do it differently. I'm going to make a split screen. So Alt this button over here, and in this one I'm going to create a scene view. So go back in, and as you can see, we have both the wave, and I can't make it any smaller. Well, I can still reduce this one a little bit and reduce that one a little bit, but that's about it. So here you see how the period is changing the size of the waves. I can also change the phase, so it's just moving it around. So it's, as you can see, it's very flexible. For example, you could have like a $F sign over here, and oops, why is it not working? I guess I know. Okay, the phase is only working from 0 to 1. Yes. Offset, this is putting it higher or lower. Amplitude, making it stronger or weaker. Decay rate, as you can see, kind of something decaying. Ramp slope. So basically all these settings right here is something I rarely use. I'm gonna go back to refer to defaults like this. So this shows you a first direct control of waves. Now, second thing what I want to show you, and I'm going to close this window down, is that there are also that you have also possibilities of combining those channels, and this becomes rather interesting. So if you start copying two of these waves, we have wave 1, wave 2, and I'm going to add a math node. This is an extremely powerful node because it allows you to do all kinds of mathematical operations just on two waves. And the nice thing about this is that doing mathematical operations immediately on data such as this gives you much better insight than what you would have if you would just have to program it out in a traditional way. So here you see like a total result of values over time, whereas if you have to program it in, let's say, something like Mel or so, you have no choice than to have it all in your mind or to prototype it all the time and to see what's going on. Right here we see what's going to happen. So if I'm going to take, for example, both of these wave files right now having exactly the same settings, well, I can say over here that I'm going to combine the chops. So two chop operators, I will combine them, for example, by adding. The result is very obvious, of course. Everything is being added, so which was 1 here and 1 over there becomes 2, and the other values as well. Now, it will become quite interesting once we start to play around a little bit with the settings. For example, I'm going to change this in a period of 2. So it's not oscillating in the same velocity anymore, but going up and down. So right here we see immediately what adding up two of those signals mean. So we could have like 3 having like up, up, down, down, up, down, down. And as you can see them both together, if you just push shift and make them visible, you see all of the waves at the same time. Why is it utterly white over here? I don't see why it is white. Let's do it over here as well. Okay, see something like this. So you see we have two of our wave files. We see over here this is from node wave 1, that is from node wave 2, showing channel 1 and showing channel 1. So right here we're combining them, and you have all kinds of ways to combine. For example, you can do subtraction and subtracting one from the other, Again, if you see both of them together, it makes perfect good sense. So if I subtract like this lowest point, which is, as you can see over here, check out the values. So what we have over here is minus 1 gives us plus, and so it adds up over here. And right here with minus 1 minus 1 gives us minus 2. And like that you have all these logical waves. But if you are just a little bit unable to really understand, it's fairly easy that you can just play around with it. And that's the cool thing about the whole stuff that you see over here, is that you can play along with multiply, with divide values, with minimum, maximum. And so if we see a combination of both of these having all the maximum values, so up maximum, then the other takes over, then maximum of the smaller again, then the big one again takes over, smaller again. You get all kinds of like really interesting patterns. Okay, so if we go back now, right here to our copy node, we still see, okay, we have this same result. Again, I want to show you how important it is to use a null node. So right now it is directly connected to the result over here. I'm gonna add a null node, tab null, okay, and I'm gonna rename it to out, makes it a bit easier. Now again, I do have the freedom right now to do whatever I want over here. I can just play around, I can make the graph as complex as I want. I'm always going to read out from this node. So that's something I do have to change right here into out. Okay, so now we have a result something like that. So right away, if we go over here to the scene view and we start just playing around again with several of these things, length, minimum, average, add, subtract. Again, everything is quite clear, and you see also the combination of all these results together. So this is showing you the direct usage, direct combination. With this I'm going to conclude the very first part, and I'm going to continue with the second part, in which we're going to go a little bit deeper into controlling sensible waveforms, and how we're going to use that to, for example, select certain objects. And this will give us the possibility to create like very interesting patterns.